reading this question, one of the things that you want to develop as a math student is when you're reading a question, there are certain trigger words that should jump into your memory and say, I know this, okay? So I see in this one, algebraically and inverses. And when I read that question, that should trigger for me, oh, algebraically, we switch x and y and solve for y. That's how we find inverses. So, and when I see inverses, it should trigger for me the algebraic way. It should also trigger graphically. That's flipping over y equals x. Take my coordinates, I switch the x and the y. All of these things that we've seen, okay? Your job in the evening, after we've had a lesson, is to try and make those things, those connections. How am I going to remember that? Because some of it will be in our memory, and some of it's going to be understanding. And we need to go back and forth, do a lot of things that we remember, and a lot of things that we need to understand. Okay. So, we'll do part I first. Are these algebraically? What we're going to do, if we want to show it's algebraically, we're going to choose one of them. We're going to switch the x and the y, and we're going to solve for the y. If they match up perfectly, then you know they're inverses. If they don't, they're not inverses. Okay? So, we get to choose one of them. My bet is all of you would choose the first one. I actually think choosing the second one is easier for matching purposes. Okay? That's something that you could do if you had a question like this. You'd be like, oh, I chose one. For me, I've got lots of algebra skills. Actually, both of them I consider equally the same because I've done so much. I can make them equal and make them match. However, I think in this case, if I choose this one, and I switch the x and the y, and now I want to get that y by itself, so first I'd have to multiply by 3. And finally, add the 6 to the other side. Are they inverses? No. They're not inverses. There's another way to show inverses that actually comes up a fair bit in the AP course. It involves composition of functions, which happens in our last unit, so I can't really show it to you here, but I can show you the idea. Remember at the beginning of the class where I said you had one function, and out would come a number, and then it goes into the second function, and it undoes it. Okay? In other words, if you would put x in, something would come out, and then when you put that back in, it has to get back to where it started. Algebraically, you'd have to show that with x. If you'd like to try that, what would happen is if my original one was 3x minus 6, if I pick that as 1, x goes in, out would come out 3x minus 6. And then you would have to plug 3x minus 6 into the second one, and you would get 3x minus 6 divided by 3, and see what you get. But I just want to show you with a number. Let's choose a really easy number to do mental math. Let's put in 0. If you put in 0 into 3x minus 6, do you see that out would come minus 6? And if I put minus 6 into the second equation, minus 6 is minus 12, divided by 3 is minus 4. Did the number come out the same? No. So that's another way we can check if things are inverses. Because if they're inverses, they should the one machine should undo the other machine, or the one function should undo the other function. Okay. Slide it up. And we'll do the second one. The second one has a domain restriction. This is probably the first time you've ever seen an equation written in a question with a domain restriction attached to it. Okay? They're saying, here I have negative x squared plus 3, which is a parabola being flipped upside down, translated 3 units up, and I have a domain restriction that I'm only taking half of it. If I do the algebra to find the inverse, did they give me the right half? That is the question. So I'm going to start off, and I'm going to switch x and y. Again, I want to solve for y, so I'm going to get that y squared by itself. I think that's probably easiest if I move the y squared to this side and the x to this side. Can you see that negative x plus 3 is the same as 3 minus x? Yes? So now I'm going to square root both sides. And I would have plus or minus. But there was domain restriction. So which one do I have? Because of the domain restriction, do I have the plus one or do I have the minus one? Okay? And I have the plus one because if the domain restriction was x is equal to 0, on the inverse, we would know the range restriction would be y is bigger than or equal to 0. So in the previous example, when I showed you 4 ways to figure out which one it was, we don't have a graph yet. So we can't really use the graph. We could draw the graph, but isn't this a lot faster? I can say I know the y values have to be bigger than 0. If that's the case, it has to be the plus one. Does it match up? Yes. Okay. I'm going to leave part B for you. If you want to find an old video of mine to check it, you can. To verify it graphically, you'd have to graph both of them and see that the x and the y coordinates have all been switched. That it's been a reflection over the diagonal line. And I made a little note that on 11 and 13 of the homework, these are examples of problem-solving questions, where initially you're going to read them, and you're going to be a little confused. And you're going to have to think of strategies and see if you can figure it out. But we want to develop our problem-solving skills as well, so I just want to note that for 11 and 13. Those will probably be ones that people come in and ask questions. But try to see if you can figure it out on your own first.